You've seen it.
I always wanted to make a doodle for Bach because his music is so stimulating and technical.
He has a style that's very concise, but at the same time, it's very rich.
People consider him to be probably the best composer of all time.
This doodle is very much tech-driven.
Combining art with technology and allowing people to create things they couldn't create before.
Bach's music, it has all the rules of how to write good harmony and melodies baked in. So it's like a really good resource for machine learning to learn music.
I would try to explain machine learning as collected data and finding patterns and structures that are similar within all that data, and then using that pattern to create something new.
Jacob contacted us and saying, oh, we're working on a Bach doodle and we would love to have some machine learning. I was like, yeah, I have such a model. That's trained on Bach music, so that's perfect.
There's an open source project that's being developed at Google, and somewhere along the
Well, I guess that's mostly about what they are, how they started this project. But anyway, well, this is a blog, but this is not what I am supposed to be opening. So this link here, should lead us to that, Bach Doodle. So this is like the archive of that Bach Doodle. Skip intro, but anyway, you know, you can sort of do something with it. What should we do? Let's drink a bit of fun, I guess. I don't know how to do half note, but anyway, let's just do it this way. Then you can do harmonize. I think there's still a lot of different things you can do. But anyway, now the model is doing something like this, you know, something like this. It's sort of like it's the we can redo it again. You like it? It's not bad, I mean. Get another one. It's not bad, but I mean, also, you know, Bach style is sort of like prominent in some sense. What did I get? You can also download the MIDI, or let's do something else, I guess. It should be easier. Hopefully. Well, interesting. I guess I don't know. I mean, I haven't played with this system. Anyway, like suggest any melody line. What are these? No idea, but anyway, you can just do different thing, and you can also set the key, I believe. And if you don't set it, I guess it would just predict it for you. But anyway, this is Bach Doodle, and it's actually doing some machine learning under the hood, and that's what we've seen here. You know, it's actually doing this sort of like you know, you have the melody line and you're sort of trying to figure out what are the other notes. And how they do it is like, you know, at the beginning, everything is uncertain. So, you know, you just erase everything and try to figure out what are the notes. And over the time, you will see some of the notes that's like more certain, then you keep it. And, you know, at the end, you sort of like reduce the rate that you erase stuff. Sure.
So how are the nodes represented in the model?
You mean how the nodes represented in the model?
Yeah, like the input.
The input is just sort of like something like image, but the model has no idea what these pixel means. So that's the interesting about machine learning is like the model at the beginning have no idea what these are, but sometimes you see that octave coming up again and again, and they sort of serve the same purpose. Then you realize they might be the same notes. And then you realize that, certain nodes are not that commonly, appear at the same time. Then it maybe means that they are in harmony. But at the same time, this model doesn't have any idea how they sound. So they also don't have the idea whether they are harmonic or not. So here we are talking about, symbolic music generation in the sense that, it's sort of like ChatGPT. You just look at, the most likely word to follow. Sort of like, does it need to understand whether what the article is talking about, or it just generates something random? But this is sort of the equivalent in music is that most of the symbolic music generation system, it actually doesn't require the model to sort of like understand music or know what the music sounds like, but it just sort of like mimic that pattern. But some of the model nowadays, we have those like audio perspective. But again, these machines are not humans. They maybe there are some clue that these models are internally doing some Fourier transform. Later we'll see. Some of the CNN, it can actually do Fourier transform in some sense, but this Fourier transform sort of do the actual music analysis. So I guess we never know, but if it can generate this music, does it tell us anything about whether the model knows it? I guess we will never know. Most of the case, I would say it's not learning the music in the way that we expect, but it's sort of like behave in the way we want it to behave like. That's a sort of like a long philosophical answer to your question, but that's sort of the thinking of how these model is working. Cool. Any question on this? This is a very fun, doodle. It's interesting because a lot of people use it, and there's an archive that they also collect whether people like it or not, and you can also share it. I think in 2019 you can also compose it, and then you can share it online. And I think they also written a paper on how people interact with this doodle. Because it's like 2019 is still early time, before this, Gen AI. I would not say bubble, but Gen AI things come up. But anyway, that's when people start to look at this. Oh, good on this. We will definitely go more into details. You will sort of like get more and more understanding into deep learning. And hopefully it will give you more sense about how these models are actually working and what these models actually learn. We will start to know about it once we get more understanding of it. Anyway, two more examples, but I won't play it. Cool. So this is another example how music can be used. How machine learning can be applied in live performance-ish thing. Even though it's not the final performance, they've done some performance, but this is sort of like a introduction video. Oops, sorry. So this was from Ear Camp in Paris. Sorry about that. That's my laptop's artifact.
Sadly, gosh, this is true. Only yet, my nerd, Angelina Nolan trying wearing people here are startled. For fencing, but see it isn't Cleats media every generous like howlers turmoil of Elon being told hello's praise I
Well, it seems very chaotic what's going on, but this is a model that's sort of trying to do that, audio codec thing that, you have a bunch of audio. Here is speech. So you have a bunch of audio that someone is talking about something. And then, you train this model that what it's doing is that, let's see if we have the original sound. This is sort of like the original sound. This is not speech, but this is the original sound coming from here. And then now you can sort of like plug it into that audio codec, neural audio codec that you train, and you can sort of like change its timbre. This is like a speech model, but now the input is that, the music, and then you sort of like change it into, you sort of like encode something, think about the case of like MP3 is that can you sort of like encode an image using MP3 codec, and what will be the output. So this is sort of like, think about this as like a speech codec, and this is not speech. So, you have music, but you sort of like encode it as speech. And then it turns out when you reconstruct it, you get the speech output. And then what's going on here is that, you're still doing that, encode decode thing. And here is like sort of like that this model to sort of like generate it by itself. So what you will hear is that it doesn't sound like speech, but it sort of have that, tiny chunk of like speech like audio.
Only yet, my nerd, Angelina Nolan trying wearing people here are startled.
So this is sort of like a interesting project that, we are sort of like training this audio codec, but we sort of want it to be generated. So this is how they work. So, we have this like some waveform, whatever it is. In the case, it's like speech signal, but you have some waveform, and what you want to do is sort of like reconstruct it. So, you will see a bunch more the system diagram later, but just think about it like audio codec. This is, you want to encode it into something, and then you decode it back. And there's a bunch of like multi-band, spectral distance, multi-band decomposition, but it's generally just doing some computation on your input. But your goal is still trying to reconstruct it. And there's also something else that, try to improve the fidelity of the output. But in general, what we are trying to do here is just to train a very high quality codec, but that can be run in very low resource. So this is what they can do. Very interesting. So try to implement it in an embedded system.
Been caught in what the name is that author. Their graduates no much of a clown. Who appears to be fascinating. Swipes it left even, and you need to still follow the pattern behind
The fancy NVIDIA GPU chip that it has the NVIDIA GPU chip on that board. Like it, I still think this is one of the coolest demo ever. So what they're doing is that at the top you see that what they're trying to do is that they try to sort of like encode the input waveform into just four just into four value, and those values has to be decoded back into that short tiny chunk. So think about your waveform is like continuously coming in. But every single, say, 100 millisecond chunk, you sort of like try to map it into just four numbers. And you want those numbers to sort of like represent the audio chunk that you have, and it can reconstruct it sort of like perfectly, or at least, try to preserve the original content. But now what they're doing is that, can we sort of like play with that, what we call latent space, but in the middle, that compressed space of just four numbers to represent the audio. So what they are doing here is that do it here with that motion controller. It sort of like detect the X, Y, Z and your velocity, your speed, your hand movements, and it translates to those numbers. And so now you can sort of like explore that space of like compressed audio space with your hand. And so you can see that it's actually generating on the fly that when the hand moved to a certain position, it generated kind of sounds. And so you can sort of like figure out where are some of the interesting sounds that you can do in your performance. Questions on this? Sure. It's a bunch. So definitely the interface is wait. So the previous one is in Max, but this one is in Pure Data. Because they need to connect to JSON Nano. There's a GitHub link so you can play with it. So this is in Pure Data, but that's for the interface. I think how they did it is they compile the whole model. They train the model in Python because most likely everything in machine learning is trained in Python in some sense. But you have to train it in Python, and then you have to compile the machine learning model into C code or C++ code, and that you can sort of port it into Pure Data. I think they also try to do it with Max, but Pure Data seems to be easier in their case. And then once they've done it, they have to put that model into the JSON board. But basically, sort of like Pure Data plus some C++ compiled machine learning model, but that machine learning model was trained on Python using some GPUs. And you can play with it. As far as I know, someone in my class last semester did it. So you can definitely check it out. It's working. You might need to install a lot of plugin, but I believe it's working. And there's a lot of ongoing discussions and issues on GitHub, but it should be working. Cool. We are so behind of our schedule. I think I would just skip this. When we talk about this, we can anyway, I'll play it, but this is sort of like a text to music generation system that's being done in academia rather than in the industry. It's like 2 years ago. But in the industry now things just move on so quickly. But this is one interesting project that it's trend stock music that you can purchase online. And at that time it's still unclear whether this is legal or not. And in academia people are still trying to figure out how to get licensed data. But anyway, this is one of the projects that they just train this model that can do text to music generation, and the quality is not what we expect today for commercial software, but this is an academic version of it. But anyway, they are doing this poetry and try to sort of like generate some music from that, and it's quite interesting. Different out of music with that, just like thousands and thousands and thousands of different songs to create that, or like yeah, the trending data is something like if you go on some stock music website, it's like those like tiny prompt that says chill music that you listen to in the cafe, or some that's like a short descriptive prompt or caption that you search for it. So that's usually I don't know what are some good analogy, but think about maybe like in Premiere Pro, you have a huge sound effect sound bank. And when you try to search it, there are like file names. And so sometimes it's like sort of like similar to file names of those stock music, but sometimes it's longer. But usually that's the type of text caption that we are using to train these models, because they're it's very hard to, I mean, I think there's like just generally no such data that, give you, very precise description of what each section of the music is doing. But that's sort of like different from the image side, that in image, usually an image, there could be some caption just right below it. But in music, it's generally people are using stock music to train it. And as you can probably hear, it sounds just very stop music like. But we can still do some interesting thing using it. I think we're back, but I just need to stop the video. Cool. Any questions on that? Well, we'll get into detail how it was trained, but I mean, at this point, I guess looking at this is sort of the thing that we are expecting in this field. Is like these are some of the more than network architecture that what it looked like. I guess just give you some flavor of how complex it could be. You see that it's actually doing some spectrogram. Here you see encoder decoder. So this is sort of, again, doing that, compression thing, that we are not generating spectrogram directly, but rather we are generating those, compressed version of the spectrogram. So we are actually generating some Y. This Y is basically the encoded version of the spectrogram. So you train some compression algorithm, think about MP3. So you have some waveform. Generating waveform is too crazy. So we just first turn it into some MP3 space, some MP3 numbers. Those are more efficient in general by design, because they have like compressed space. And then what we want to do is generate those. And then once we have those, then you can sort of like decode it back to the original waveform. But anyway, at the bottom, you will see that this is like that latent diffusion model. We will talk about it later, but this is the most of the current music generation system or image generation system are based on. And everything you've likely heard in machine learning is using latent diffusion model. Even though it calls latent diffusion model, it's actually using diffusion model, it's using generated adversarial net, it's using transformer, it's also using CNN. So it's sort of like use everything that we know in deep learning, those advanced network architecture. We will learn about it over time, slowly, hopefully. But this is sort of like what we will end up with at the end, that once you know all these different components, that you can build such model that's being used currently in lots of the machine learning model. But I guess the takeaway here is that this is something that's being used in practice, and it requires some understanding over into how these different components work. But at the same time, if you look at it as a system, it's just looking at the input and the output and think about the data, you can already learn a lot about the system without knowing all the detail working of it. Cool. And the last one is another very interesting demo, is doing freestyler. But anyway, this is pretty new. This is like Triple AI 2025. So it's just been on, it's like less than 6 months. Where's my cursor? Well. I would just play the demo. Well, what's going on? Actually, I think one of this is Trump doing something. but I will play the other one. So here, what they want to do is, let me show the original. So the input is some lyric, and you have the accompaniment. So here is like you have the accompaniment already, but you want to sing with that, or rap with that. And so once you get the vocal out, this is the model. What the model is doing, you have some lyric and try to rap on that accompaniment, and then you just combine them to get the thing. So here, what they did is it's kind of funny because they have their paper abstract, so they just use ChatGPT to redo their abstract and generate.
Yo, second. We got freestyler on the mic, no debate. The first system is direct, but raps is truly great. Lyrics, the vocals, no delay, that's how we generate. From words to beats, we innovate, no need to imitate. Freestyler, we got can flow with a model that'll go. Token generation, spit and fire, watch it grow. Spectrograms and vocal to every beat in its own. 3 seconds to control the tone. Yeah, we own the throne. Quality sound, natural vibes all around. Match rhythm styles profound, beats and flows are found. Rap X the name with a dead is renowned. 92,000 traps, the 1,000 hours of sound. I can face and get hard, yeah. Where's out? Rap X got the data and the beat so foul. Freestylers on the rise, nigga, rap track style. Step into the future with the freshest sound tonight.
Anyway, you see a lot of keywords that's actually being used in their abstract, and they just sort of like the model just extracted to generate the lyric. Anyway, we will talk about it in the future. So this is sort of like the current state of the field, that you have like rap generation. You also have that singing voice synthesis model, and nowadays the norm is to sort of like sing your abstract. So it's like become crazy and crazier nowadays, that the demo that you need to do with your paper is to sing your abstract or do something with your abstract. Doesn't make much sense, but it's fun to see how these models. Cool. I guess the idea is just to give you some idea what some of the AI music model, and we are running out of time. We got 10 minutes left. Let's see what we can do with that, given some of the technical issue. Anyway, today we are supposed to be doing some machine learning fundamentals, but we couldn't make it. But anyway, let's see what we can do. At least you can get a sense of what machine learning is. So now we would dive in a bit more on the technical side. That's sort of like the thing that you need to sort of like understanding what's going on. And after this, we will also talk a little bit about music and audio processing. Hopefully that should be easier. How you represent music, it's like waveforms, spectrogram, and there's a bunch, and also like sheet music, how do you represent it? So there's a bunch of things that we should talk about before diving into some of the application. But this is sort of like an introduction to machine learning. It's very high level. If you want to learn more about machine learning, you definitely should take a course on intro to machine learning or whatever machine learning course. But this is just a way that to talk about machine learning in the very simple form. So just a quick recap. What is artificial intelligence? Again, this is my favorite definition of it. It's like the study of how to make computers do things at which at the moment people are better. So it just keep changing the definition. And so once again, that AI, ML, and DL, artificial intelligence, machine learning, and deep learning is different terminology, even though nowadays some of the blog and news article, they tend to just like morph them or like use them interchangeably, but there are 3 different things. So AI is the biggest thing. It started like 1950-ish. Anything that behave like humans or depends on your depending on your definition of AI, it's like it can think like humans, behave like humans, think intelligently behave and have like intelligent behaviors. But in general, that's anything that's, intelligent. But machine learning is like one kind of, one subset of like AI algorithm that just trying to do this by learning from data. So it has to be data driven. And it started like 1980-ish, and you can see the pattern 2010-ish. Usually we call the start of the deep learning boom recently in 2012. So, that's algorithm that learn from data. So it's part of machine learning, but specifically it's using deep neural networks. But anyway, that's the difference between the good old AI versus today's AI that you usually know about, because most of the AI system that we are talking about, a lot of it are actually both based on machine learning, and machine learning is based on data. So, this is the key difference from traditional AI. So you can think about traditional AI is like human is actually the intelligence in that. Think about rule-based system. How do you think about musical dice game? There's nothing too intelligent in that system. That system is just, it doesn't have any system in general. It's just like, it's just a table. It's human that learns how to grab that pattern and sort of like make it into the form that you can play with it. But more than AI system, what we want to do is that can we learn from the data and automatically get that up? So some of the definition of machine learning, don't need to worry about it, but sort of give it a sense what people think about machine learning. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. So this is interesting. So, what we want to do in machine learning is actually not programming. So we program so that we don't need to program. So that's the idea of learning about machine learning. It's like, people are like, you have to code for machine learning, you have to do Python, but the way what we want to achieve by programming is not to program in the end, that you don't need to sort of like, when you see this chord, you use that note, or, you see this melody line, you use this chord, but rather you want this model to sort of like do it for you. So you program the machine learning algorithm, but that machine learning algorithm is what it's trying to do is to give you some algorithm so that you don't need to explicitly program that algorithm that's doing the desired task that you actually want. A more technical definition is a computer program is say to learn from experience E with respect to some class of task T and performance measure P, and then for its performance at task in T as measured by P improves with experience E. Very technical definition, but we will see why it makes sense later. But in general, how you should think about machine learning is that at the left is how we do algorithm in the past. You have some input. Think about, I don't know, what are some algorithm that we want to do? Sorting algorithm maybe. Think about the input is a bunch of numbers that is unsorted, and then you want to figure out how to sort it out. So, this algorithm, what it has to do is to sort of like compare different numbers and try to reorder them. But this is different from machine learning. So machine learning is an algorithm that it wants to generate a model. So what it's doing, that machine learning algorithm, what we call machine learning algorithm, is actually doing this, pattern learning thing that it wants to figure out how to get this model that can do that, input output matching automatically. So once you're done with this training, you grab that model to do the actual task that you're interested in. So this is the biggest I guess confusion in machine learning sometimes. If you think about machine learning as a field and why what the field is going on in terms of how to develop machine learning algorithm, people are looking into the way how to make the left part efficient. We are thinking about how to build new machine learning model that can better learn this model that do the thing that we want. But think about applied machine learning, or think about how machine learning can be used in music. We are focusing on the right-hand side, that how actually this model is being used, and how do we design the desired input and output. Think about the piano genie work is like, how do we figure out that we potentially want that A button interface. So you are thinking about creatively about how you define the input and output space, and then try to figure out a better machine learning model that serves your purpose. So that should be the way of thinking about machine learning. And that's one big caveat when you are looking into some literature or looking into the field of machine learning. So applied machine learning is different from machine learning. So machine learning is focusing on figuring out the best algorithm that can get you the model that you want, that describe the input-output mapping. But applied machine learning is looking at the downstream task of the actual application domain, and how can we better view a model or than the machine learning algorithm, so that we can achieve our goal. So sometimes their objective is different. Anyway, let's go back to this definition, improve on text T with respect to performance metric P based on experience E. So here are just some examples that, how do we figure out machine learning in this definition. So I guess the first example is animal classification. So if we want to have this machine learning model to do animal classification, what would be the performance metrics like? Any clue? Yeah. So percentage of correct predictions. So this is like the performance metrics that we are referring to. But at the same time, it could be something else. You can also think about, if you're interested in a specific category, then it could be, how good you do well. You can also think about the average, or, the standard deviation of all the predictions. Say, maybe the model hasn't seen a lot of, like, I don't know, bear image, then it do pretty bad in that bear image. Then in that sense, your performance metrics would change. So it depends on your performance metrics to define the machine learning model. And usually we call it the loss function. And experience Z, just a bunch of images with labels. So this is sort of the way that you can start thinking about the technical definition of a machine learning model. So, think about stock price prediction. What could be the performance metric? Yeah. Yeah, like your prediction and the actual value. So that's it. And what's the experience E? Sort of like the data, the training data. And glue. That's it. So historical stock price. So this is one of the paradigm of machine learning, is that you don't actually have any information about it, that you are looking into the past and try to predict the future. So that's what we call self-supervised learning. And it's sort of like ChatGPT-ish. It's like, given all the past numbers, what is the most likely number to follow? So, in some sense, stock price prediction is sort of also similar to ChatGPT. I guess we can end here, but do you want to guess what these two companies are? The left one should be relevant to this course. NVIDIA. Yeah. What about the other one? Nope. Close enough. It's AI-ish, but not AI-ish, chip-ish. Nope. AMD is doing well.
Yeah, so
Yeah. Yeah, that's Intel. But you know, that's September 2024. But anyway, it's interesting, you know, seeing Nvidia just booming at some point. You know, this is 2024. It could be longer, but at some point during COVID, it just boomed because people are using more and more GPU, and you know, Intel just somehow didn't work well. But anyway, we can talk about it later. Cool. See you on Monday. I will release the homework hopefully soon today. Don't worry about it. Yeah.